Chapter 12 is about probability, data, and statistics. So, in this particular question, it's asking, referring to conditional probabilities. So this is reading, find the probability someone is a woman given they are 69 or younger. So you are only concerned with those that are 69 or younger. So of the total number of people who are 69 and younger are 75. So that's going to be your denominator. So of those 75, how many are women? So look in the green part and it's going to be 40. So I'm just going to answer to the nearest percent. So 40 divided by 75 is approximately 53%. So the second one is find P of 70 or older. So find the probability of 70 or older, given it's male, or the person is male. So look at the males. The number of males the total is 40. So that's going to be your denominator. Now of those males, how many are 70 or older? That's 5. So writing it to the nearest percent, 5 divided by 40 is equal to 12.5%. And to nearest percent, it would be approximately 13%. And then C is just find the probability somebody in the village is 70 or older. So you want to look at the total number, which is 100 people. How many people are 70 or older? So that's 25. So that's 25%. Okay, number 28, use the data below to answer the questions. So I put these numbers in go into L1. And then after you do L1, you want to calculate the first variable statistics. So in my first variable statistics, I have that the Q1 is 14.5. The median is 16.5. The Q3 is 19.5. And then I can find the min and the max just by looking at my data set. So the minimum number, these are all in order, is 12, and the maximum number is 22. So making a box and whisker plot, what I want to do is make a scale. So I'm going to make my scale I'll go from 10, 15, 20, 25. So you just want to make sure the distances between these two are between here and here, and between here and here, and between here and here are the same. So that means that you have a good scale. So I also want to see if there's any outliers, because the outliers would be not on my box and whisker plot. So to do my outliers, I need to find my IQR. So my IQR is going to be 5. So I'm going to do Q1 minus 1.5 times the IQR, which is 5. And I'm going to do Q3 plus 1.5 times the IQR, which is 5. So Q1 is 14.5 and Q3 is 19.5. So if I do 14.5 minus 1.5 times 5, I get 7. So anything that's less than 7 would be an outlier. So there's no outliers that are on the lower side, and then I'm going to do the upper outliers. So 19.5 plus 1.5 times 5, and that gives me 27. So nothing is greater than 27. So there's no outliers. So I'm going to include everything on my box and whisker plot. So I'm going to draw 12, which is approximately right here. My minimum value and my maximum value is 22, which is approximately right here. The median is 16.5. The Q3 is 19.5, and the Q1 is 14.5. So once you have your 5-number data summary, you want to make the box and the whiskers. Okay, B, determine the number of standard deviations within the mean the data fall. So going back to your first variable statistics, notice that the mean is 16.9. So I'm going to do 16.9 and put that in the middle on my number line. Now, the standard deviation is 2.9. So I'm going to go up 2.9 and back 2.9. So I'm going to add 2.9 and subtract 2.9. So I do 16 16.9 plus 2.9, and I get 19.8. And then I do 16.9 minus 2.9, and I get 14. So everything that's in the red that's greater than 14 and less than 19.8 is one standard deviation away. So you want to check your numbers. Are all of these numbers greater than 14, less than 19.8? And I say no, because these are not included and neither is 12. So I'm going to have to go another standard deviation. So that would make 2. So I'm going to add 2.9 again and subtract 2.9 from 14. So if I do 19.8 plus 2.9, I get 22.7, which 22 is right here, and that's in my data set. And 12 would be right here. So now these, from here to here, would be 2 standard deviations away. So the answer is 2. Okay, letter C. Find the z-score of 16 in the data set. So the z-score formula is your data minus the mean, which is 16.9, and you divide it by the standard deviation was 2.9. So I have rounded these values to the nearest tenth. So if you go in, you could be more accurate if you kept these numbers to maybe 5 or 6 decimal places. So 16 minus, I'm just going to do the tenth. 16 minus 16.9, press enter, and then divided by 2.9. Or just at least make sure that you put the top in parentheses, because a few people messed that up on the test. So 16 minus 16.9, enter, divided by 2.9 is negative 0.3 to the nearest tenth. And then define the 20th percentile. So I'm going to take 20 as a percent is 0.2, and I'm going to multiply it by the number of numbers in my data set, which was the last number. 22 was the 12th number, so 12. So 0.2 times 12 is 2.4. So I'm going to round that to 2. So I'm going to cross off 2 and go to the third number. So go back to your L1, and you want to make sure that these numbers are written in order. You actually want to make sure that your data is in order by using the sort ascending feature, sort A L1. So I want to go to the third number, which is 14. So the answer is 14. Okay, 29. Find this out of 252 juniors, 206 are in Algebra 2. Find the sample proportion of the juniors in Algebra 2. So that's just the ratio, the fraction. So it's 206 divided by 252. And I'm going to round that to the nearest percent. So 206 divided by 252. So that's 82%. Now we don't know if this is a sample proportion, because we don't know how many juniors are in this particular school. So it could be, you could have 1,000 juniors. You could have 500 juniors. So the key word was sample. So not everybody, but of 252 juniors that we asked, 206 are in Algebra 2. So there's going to be some type of margin of error if you're not asking everybody. So the margin of error formula is plus or minus 1 over the square root of the number of people that you asked or sampled. So in that case it was 252. So I do 1 divided by the square root of 252, and you get 6%. So it's plus or minus 6%. Make sure you put positive and negative. So because we have this margin of error, we sampled and found 82%. We have a margin of error of plus or minus 6%. So we're going to get an interval, a likely interval that we think would represent the percent of students in Algebra 2 of the juniors. So I'm going to take 82% and subtract 6%. So it's going to be 76% to 88%. So if we found out in this school that only 40% of the people were in Algebra 2, that would be very unlikely, because it's not in this likely interval of people that we sampled. Letter C, find the margin of error. If the margin of error is plus or minus, this should have a 10% right here. Approximate the sample size. So I'm going to use the formula, margin of error. So I don't know what that is, or I know it's 10%, so I'm going to just do the positive, equals 1 over the square root of n. So I need to solve for n by multiplying both sides by the square root of n. So I get square root of n times 0.10 equals 10. So I'm going to divide both sides by the square root, or by 0.10. And then I'm going to get rid of the square root by squaring both sides. So 1 divided by 0.10 squared is 100 people. Okay, so 100 people.